The delivery of atomic weapons by light carrier aircraft is one of the fleet's strongest retaliatory weapons. The responsibility for a special mission rests primarily with each pilot. The success of his mission depends on the thoroughness of his pre-planning and his ability to carry through those plans to completion. This film will show the planning and execution of a typical atomic bomb attack using a light carrier aircraft. Let's follow this light attack pilot to find out just how he prepares for a special mission. He has just left his initial briefing where he received a specific target assignment, intelligence, and strike information. All the information he'll need will be in this target folder. The folder includes all available information on a particular target, such as target mosaics, standard navigation charts, target graphic intelligence book, target information sheet, and checkpoint photography. From the briefing, the pilot knows the weapon he will use, its yield, burst height, and latest enemy intelligence. It's all up to the pilot now to plan his mission in detail, from launch to return. The first and most important decision he makes in planning is the type of weapon delivery he will use. He has 5 types of delivery methods available: the low-angle loft, medium-angle loft, high-angle loft, dive bombing, and lay-down bombing. The low-angle loft method is an approach to the target just off the deck, a programmed pull-up prior to the target, release to get maximum distance in the weapon trajectory, and a wing-over for escape. The medium-angle loft method is identical to the low-angle loft, except that the weapon is released at a higher angle, and the pilot uses a half Cuban 8 escape maneuver. The medium-angle loft method offers a maximum aircraft burst separation. In the high-angle method, or over-the-shoulder delivery, the pilot may use an initial point to determine where to start his pull-up, or use the target as the pull-up point. The dive bombing method differs from conventional dive bombing only in the higher release altitude to allow the pilot to escape weapon effects. Lay-down bombing permits delivery under adverse weather conditions and is the most accurate method of all. The pilot may choose 2 of these methods, a primary and an alternate type of delivery. To select the primary type of delivery, he studies the conditions of his mission as outlined by the Air Intelligence Officer. He knows that he will use a Mark 7 weapon, and that the Mark 7 can be fired in 3 ways: a radar airburst, a timer airburst, or a contact burst. With the facts available, the pilot decides to use one of the loft delivery methods. Now he must examine his Mark 7 loft delivery profiles in the OpDev 4 Pilot's Delivery Handbook to find which loft method will best fit under the given conditions. In considering each method, the pilot asks himself the question, do I have sufficient probability of escape from weapon yield? In other words, using a given delivery method and bomb yield, will he be far enough away to escape the effects of the bomb blast? From the Mark 7 loft delivery profiles, he determines that for the assigned yield and burst height, either the low, medium, or high-angle delivery would provide a safe escape. However, a medium-angle delivery offers two important advantages over the low-angle delivery. First, medium angle provides a maximum aircraft weapon separation. Secondly, it permits the pilot to use radar fusing, the most accurate fusing method for an air burst. He chooses the medium angle delivery as his primary method, since, in this situation, it does meet all requirements of his mission. The medium angle loft method requires a pull-up prior to the target. The point where pull-up begins, called the IP or initial point, is selected from the Target Graphic Intelligence book. This book contains small-scale charts with annotations depicting target information and suggested IPs. With the target as center, he scribes an arc in the approximate direction from which he will approach the target area, using the pull-up to burst range as the radius of this arc. Since his lab's timer can time for a maximum of only 30 seconds, he determines the distance his aircraft will travel in this time at his true airspeed. Then, with the target as center, he scribes another arc with the radius equal to the pull-up range plus the distance his plane travels in 30 seconds. His IP must lie between these two arcs. He now scans the area between these two arcs in search of a good IP, avoiding the choice of an IP too close to either arc to allow for wind correction. Small lakes which may have dried up, or man-made structures which could be removed, should be avoided. After choosing his IP, he measures the IP to target distance and draws a line from the target through his IP. The line extends well beyond the IP for marking advance checks. This establishes a track, so he hits the IP on a straight run. There should be no maneuvering after the IP. From the IP to target distance, he subtracts his pull-up range to obtain his IP to pull-up distance. By dividing this IP to pull-up distance by his true airspeed in feet per second, he obtains his no-wind lab's timer setting. Having worked out all details for his primary method of delivery, the pilot may decide upon an alternate method. He chooses the high angle or over-the-shoulder delivery as his alternate method. This method has an added feature in that should he miss his IP, he can switch to instantaneous over-the-shoulder and pull up over the target. The pilot now chooses the bomb fusing settings for his primary and alternate methods of delivery. The 2,200-mile round trip with a low-level run-in and escape will take one in-flight refueling. He decides upon refueling 500 miles after takeoff at 33,000 feet. A high-altitude refueling is best because jets run more economically at high altitudes. The pilot completes his profile with power settings, altitudes, and checkpoints. After working out all details of his mission, he will submit it to the Air Group staff, where every step of the mission will be double-checked. It's early dawn as the A-4D Skyhawk is spotted on the catapult. Shortly after takeoff, the bomb fin is lowered. Refueling point with the buddy tanker is reached, and the fuel is transferred. The pilot now continues on the mission, while the tanker returns to the ship. When well clear of friendly forces, the weapon is armed. 80 miles from the enemy coastline, a letdown is made to 50 feet for the run-in. The selector switch is set to labs to allow warm-up time for the lab's gear. Approaching the enemy coastline, he looks for his landfall checkpoints. There they are, the cove and the river. He keeps a sharp lookout for enemy fighters and skirts populated areas to avoid ground fire. Now, with a good navigational fix, he checks the surface wind, apparent drift, and ground speed. At the same time, he must keep a close watch for his navigational checkpoints, a river bend, and a bridge. Good navigation planning makes use of the nature of the terrain. No time should be lost in searching for a checkpoint. He keeps as low as possible and flies through valleys to avoid detection. The approach to the IP, or initial point, be as steady as possible. For after the IP, there should be no maneuvering. Wings are level, and all arming switches are on. Now, he compensates for drift due to crosswind and corrects the run-in time on the lab's timer to compensate for a headwind or tailwind. Taking into account the outside air temperature and run-in altitude, the pilot checks the pre-computed run-in indicated airspeed. The lab selector has been set to the loft position. At the IP, the pilot presses the pickle to start the timing run, keeping the pickle depressed during the entire run until after the release of the bomb. At the end of the timing cycle, the pilot commences pull-up when the lab's solution indicator light and tone come on. He smoothly applies back pressure, maintaining a constant 4G load. The bomb will be released automatically at the release angle preset into the lab's gear. The recommended escape maneuver for the medium angle release is a half Cuban 8. At the time of the air burst, the aircraft should reach a safe escape distance well beyond the reach of any of the bomb's harmful effects. However, if the pilot missed his IP, another approach to the IP may destroy the surprise element of the mission, would lower the probability of a successful penetration to the target, and would almost negate the possibility of a successful escape. Instead, the pilot continues in toward the target, which itself becomes the new IP and pull-up point. He changes the lab's angle selector switch to instantaneous over-the-shoulder, the option pre-planned for this delivery. When directly over the target, he depresses the pickle and pulls up at a constant 4 Gs. holding the pickle down until release is effected at about 110 degrees above the horizontal. The maneuver is completed with a half Cubanate to the escape area. You have seen how an atomic weapon is delivered by a light carrier aircraft. How the pilot was given certain conditions to incorporate in his planning. How he formulated a sound, intelligent mission using all information available to him. The actual delivery was an accurate execution of his pre-planning. With the light carrier aircraft and highly mobile task forces, the Navy extends the range and improves the accuracy of atomic weapon attacks, a vital factor in the total capabilities of the United States for action against any aggressor.